Hello and welcome to the final project presentation. My name is Intumpa Mwanza and I'm presenting you a research project on predicting natural language inference. And this is the outline of the presentation. So we'll start with the introduction, introducing what natural language inference is, the motivation of the research project, the project description. Then we'll move on to the data description, talk about the model description, the model evaluation and results, and finally, the conclusion. The introduction. Natural language inference is the task of determining whether a hypothesis is true, entailment, false, a contradiction, or undetermined, a neutral, given a premise. The semantic concepts of entailment and contradiction are central to all aspects of natural language development of semantic representations. Truth values include entailment, contradiction, and neutral. Entailment means the hypothesis must be true as the premise is true. Contradiction indicates that the hypothesis can never be true if the premise is true. Neutral pertains to the scenario where the hypothesis can be both true and false as the premise does not provide enough information. What's the motivation? So our motivation was and is to have a deep understanding of why entailment and contradiction is fundamental to understanding natural language, inference about entailment, and why contradiction is a valuable testing ground for the development of semantic representations. The project description. In this project, we determined whether a premise sentence is entailed, whether the premise sentence is neutral, whether the premise sentence contradicts a hypothesis sentence. To achieve our project goal, we introduced the Stanford Natural Language Inference Corpus, which is a fairly new and is a freely available collection of labeled sentence pairs written by humans doing a navel-grounded task based on image capturing. So what's the data description? So here we use data from the Stanford Natural Language Inference Corpus, which is a collection of 570K human-written English sentence pairs manually labeled for balanced classification with the labels entailment, contradiction, and neutral. It supports the task of natural language inference, also known as recognizing textual entailment. The corpus is designed aiming at serving both a benchmark for evaluating representational systems for text as well as a resource for developing NLP models. The corpus is in JSON format, which is a Java format. And when we downloaded it, we uploaded it into our Python Jupyter Notebook format, and that's the format we used to build and run our code. The model architecture. We extracted a 300D word vector from the fixed globe vocabulary from GitHub. We passed this 300-dimensional word vector through a ReLU translator. We encoded the premise and hypothesis sentences into the same encoder. We concatenated the two 300D result sentence embeddings. We passed through 3 layers of 600-dimensional ReLU layers. And finally, it passed through the 3-way softmax function. So the neural network classifier. So we use the neural network classifier model to train our dataset to analyze the relationship between premise and hypothesis. So we split the dataset into 3 parts: the premise, the hypothesis, and the labels. Then we tokenized the data and we set parameters of the encoding model. Then we downloaded the pre-trained model, which is the glove.840b.300d.text from the Glove model website to train the SNL dataset. So this is a neural network classifier architecture. You can see on the diagrams from the bottom, after the translation, you can see the input of a 300D premise and the 300D hypothesis. After the input into the 300D ReLU, the function of the ReLU is activated and processes the data. So it processes the data by training the data, and also the advantages of using the ReLU function is it trains the data faster, and also its performance is very good in terms of the output. So after the 600D ReLU trains the data and passes the output to the 3-way softmax. So the 3-way softmax function or software, the main function is the one which is going to make a prediction of the output. It will use the probability from it uses the probability of the output to produce results based on what the probability is. So results after training. So we had 15,475 total parameters, and from that we had 1,875 trainable parameters and 10,000 non-trainable parameters. To be specific, we had 10,906 non-trainable parameters. So this is some of the model evaluation results. So here we've just displayed four rounds. So the first round, the text was a woman with a green headscarf, blue shirt, and a very big brim. The hypothesis was the woman has been shot. Predicted judgment as an entailment. The second round, the text was an old man with a package pauses in front of an advertisement. The hypothesis here was a man pauses in front of an ad. The predicted judgment was an entailment. In round 3, the text was an old man with a package pauses in front of an advertisement. The hypothesis was a man pauses in front of an ad for beer. Predicted judgment is neutral. In the fourth round, the text was an old man with a package pauses in front of an advertisement. The hypothesis, a man walks by an ad. The predicted judgment, this was a contradiction. So, continue further with the model evaluation and results. So the glove.840b.300d model is a good model for the SNLI datasets. The accuracy is 0.82, which is enough for inferencing sentences for realistic problems. So we can see from our figures below, the first one, you can see the accuracy of training data was at 0.82. Then the validation accuracy was at 0.83, and the test accuracy was 0.82. So from the outcome of our model, we can see that SNLI datasets are mature to train natural language inference models, and the model we used performed well for this data. The accuracy for training, validation, and test was between 0.82 and 0.83, which can inference a relative better output. Our conclusion. So our conclusion is natural languages are powerful vehicles for reasoning, and nearly all questions about meaningfulness in language can be reduced to questions of entailment and contradiction in context. This suggests that natural language inference is an ideal testing ground for theories of semantic representations or representation, and that training of natural language inference tasks can provide rich domain general semantic representations. And this brings to the end of my presentation. Thank you for your time.